the science guy. Bill Nye the science guy.
Science rules.
Bill Nye the science guy.
Inertia is a property of matter.
Bill
T minus 7 seconds.
Bill Nye the science guy.
Featuring the super scientist.
Boyle's law states that the pressure and volume of a given mass of confined gas are inversely proportional if the temperature remains unchanged within a closed system. The equation is P1V1 equals P2V2. Charles' law states that at constant pressure the volume of a given mass increases or decreases by the same factor if the temperature increases or decreases. The equation is V1 over T1 is equal to V2 over T2. Dalton's law of partial pressure states that the pressure of a gas mixture is the sum of the partial pressures of the individual components of the gas mixture.
Avogadro's law states that volume and the number of particles of gases are directly proportional to each other. The derived formula is V1 over N1 equals V2 over N2. Gay Lussac's law states that as temperature of a gas increases under constant volume and number of particles, the pressure of gas increases. The derived formula is P1 over T1 equals P2 over T2. Graham's law states that rates of diffusion of a gas at the same temperature and pressure are inversely proportional to the square root of their molar masses. The derived formula is V1 over V2 equals M2 over M1 of the square root.
Combined gas law is the combination of Boyle's, Charles, and Gay Lussac's law. The formula is V1 times P1 divided by T1 is equal to V2 P times P2 divided by T2. Ideal gas predicts how temperature, pressure, and volume of gas depend upon the number of moles of the gas. The formula is P times V is equal to nRT, where N is the number of moles and R is the ideal gas constant.
Yeah.
Oh my god. I think Gay Lussac's law is very interesting. How about a project of that? How about it? Think about it.
Let's go to the Super Lab!
Paulina, what materials are we using?
For this project, we're going to use a plate, a candle, a beaker, and water.
Okay.
Yeah.
We're going to put 150 milliliters of water into the plate.
To measure pressure.
Secondly, we're going to put the candle in the middle of the plate, which we're then going to light. Now we're going to light the other candle. Fire.
Now we're lighting the candle inside the water.
What are we going to do now?
Now we're going to place this flask on top of the candle. Creo que no va a servir.
Tiene que subir, no hay suficiente agua.
Eso te estoy diciendo.
Ah! It's going up!
Wow, that's so cool! Superheroes, what really happened in this experiment? We have to find out. Let's find out.
Maybe we can find the answer in here. Here it says that while the candle burned, it was using the oxygen that was found inside the flask. It is heating and expanding the air inside the flask. Some of the air molecules are forced out of the flask, because they are being consumed. After the candle goes out, the source of heat is obviously removed, and the gas molecules cool. As a result, less air molecules and the temperature cools down, making the pressure decrease. The decreased pressure is due to the fact that there are less gas molecules and slower collision between them. But Paulina, why did the water rise?
The pressure outside is greater, causing the pressure outside of the flask pushing into the water, making the water rise.
Oh, well, that makes sense. That's so cool.
It's super cool. Now, as part of responsible super scientific committee, we are gonna clean the lab.
Clean the lab. Clean the lab. Clean the lab. Clean the lab. Clean the lab. We hope you enjoyed our lesson
And hope you tune in to the next
Bill Nye the Science Guy
With
featuring
Super Scientists.
See you next time.
Bye.
As always, solve the scientific mystery. Now we're gonna put the flask into the candle.
No está prendida. No está prendida, perdón. Es que estamos makeover.
What do you think about our super scientific project? I think it's super cool! Super cool!